Hi everyone, my name is Tonian Robinson. I'm here representing the user services at USGS. I am a contractor. My contractor's name is Earth Space Technology Services. It's not on my name tag, so I have to say it on the video, so they know I said it. So today I'm really honestly just going to talk about what we have for our users, what we started in the past 2 years, and how we're getting users started in working in the cloud with Landsat. Disclaimer. I was actually thinking, what do I have to offer this community? I spoke to a variety of people, and I guess it's really just perspective on our users. What we offer are really intro scripts. Like, we have users who are not, they're not Python coders, they're just learning, or they have no idea how to, even create environments, etc. So a lot of our workflows start from the basics, and they're slowly getting more advanced. So let's get started. So yes, Landsat data is in the cloud. We are in AWS in an S3 bucket called the USGS-Landsat. Unless you're looking for level 3, then it's USGS-Landsat-level 3. It requires direct requester pays to access the data, and it is in the US West 2 region. The data that's available in the cloud are, of course, level 1, level 2, level 3. I've broken down this slide in the manner of which we have the data separated in the cloud. They all have unique names to refer to the different product grouping that you would like to access. For example, level 2 surface reflectance is under a separate. It's grouped separately from level 2 analysis ready surface reflectance data. So in a sense, this presentation is really just we are grouping them separately. So the product structure. So this is an example using a single Landsat product from the surface reflectance data sets. And what I'm really showing is we have multiple files under each product structure in the cloud. These files range from the band files to the metadata files and various other files that relate to quality assessment. And of course, these files vary based on the type of data set you're looking for. Surface temperature for Landsat 8 and 9 will have band 10 and et cetera related to surface temperature. I jotted down that link to show you guys. I actually have a longer talk, which is in the form of a webinar that is going to be published soon by the USGS. They're currently editing the video. We did it last week. This is like a truncated version where I'm just like Fruit Ninja in some slides. So how do we find Landsat data? Simply put, we have a Landsat STAC API, and it's split into the catalog. Of course, you guys saw a lot of STAC talks today. Our catalog is the Landsat Collection 2, which is the most recent processing of all the Landsat archive. And that should not be confused, of course, with the STAC collections. That's just how we call the current archive of Landsat data, which we're on Collection 2. As I was saying before, the collections are separated based on different product grouping types. Right now, surface reflectance is different from surface temperature level 2, and they all have their specific names to access them. We have individual items within each Landsat STAC collection, and these items are really just your products, your scenes, and they come with various ID properties that relate to the scene. We then have the assets, and within the assets you'll find the bands, the S3 links to access those bands in the cloud through STAC, interacting with the STAC API. So this is our new venture. We have a GitLab, USGS User Services GitLab, where we're now housing tutorials for users who have no idea how to get started. Here are some example workflows to get started. You'll see that we have 4 projects currently on our GitLab. 3 of them pertain to processing in the cloud, and one of them, the machine-to-machine, is really how most currently most users access data. I do have tutorials in those. And to be honest, most of my users, they're actually sending me in scripts that are related to machine. It's a lot of machine-to-machine users out there. So another breakdown, accessing, we have these are the 3 cloud-related tutorials groupings that we have on GitLab. Accessing is really how to access the various ways you can access. I have tutorials related to just using R requests to interact with Stack to access data, or R requests meaning the Python request package. And then I have a tutorial, for example, that uses PyStack for users who want to use PyStack. And in processing right now, that is growing. We have multiple tutorials that focus on anything from scaling Landsat 1 versus 2 to now I just uploaded a compositing one. And in case studies, that is also quite new. We worked recently with NASA Severe because they wanted a compositing script for the Ucayali Valley in Peru. And the deal was I help you create this script and you let me make it a case study, and now it's up for the users to view. It's very long. So the link to accessing, sorry I don't have QR codes or all of that. But yeah, accessing Landsat in the cloud. I'm just gonna go through some of a little bit, just a slight overview of a few of the products that we have under these groupings. So accessing, for example, as I said before, we have a Landsat STAC. We have a basics to Landsat STAC for users who know nothing about STAC. What is it, and how does it relate to Landsat? There's an entire Jupyter notebook that discusses the Landsat STAC, breaks down the links and how to access it. For this case, it's only using requests. A next tutorial that we have is querying. A big thing and a big challenge I see users have is how to search for Landsat data with STAC. And this one breaks down all the various ways you can search and how to set up a search with STAC to search for Landsat data using the various parameters that come with your data sets. So in processing, an example of processing is decoding the PixAQA bit for masking, because we know the PixAQA band in Landsat, it really is just a quality bit that tells you any faults that are present in various pixels. And here I provide this very long section of how to decode a bit, what is happening in the background of decoding the bit, what all these arrows and those greater than signs mean. If you decode bit, you understand what I'm saying. But yeah, what all that means in the background and how you can decode a PixAQA band to filter out whatever obstructions you want to remove from your pixel. And in this case, it was just snow and ice in Vancouver. This one was kind of fun, a bit biased on my part. I did my PhD at USF in Tampa, and my focus was in SAR with satellite, with sinkholes, and I've already been at this sinkhole, on it, around it, everywhere. And I was like, oh, I wonder if I can make a tutorial related to Landsat for this sinkhole. So in this case, this one is focused on how to use indices, how to pull in a single pixel, how to process that single pixel through time, and in this case is how can I see this sinkhole in the normalized vegetation index, and what would that look like? And if you don't know what the normalized vegetation index is, it's really just that index of, let's say in range-wise, the lower the value, the less likely it is vegetation, while the higher it's considered healthier vegetation. So I created this to see, can we see this sinkhole? And you can see changes in this single pixel related to the sinkhole collapse, where the NDVI it drops for a minute and then increases as vegetation in the pixel increases after the sinkhole collapse over time. So this one is just really it's low-key a time series tutorial, but I don't call it that. I call it retrieving a single band in time. Yeah, it's really time series. It's like it's the basic time series introduction for users. And lastly, case studies. this is my baby. This one is like my newest baby. I also work on the compositing team. Well, I work for NLCD also, the NLCD team. I am on the research and development team, so I am a developer on the compositing scripts. So it was cool that NASA Severe reached out to us, and then I happen to also be on user services, so I created this workflow for them to create composites for the ukulele valley, and it really just included just breaking down the site. To start, it was a huge area. It spanned 2 time zones, so that, I had to create this workflow that broke down the area in small windows. In a sense, I was making ARDs on the fly and processing each window separately through time for a single year, since it's an annual composite, and then outputting a single composite window for each window. And then in the end, it concatenates everything, like mosaics, everything into the image of the valley. I should have put that image here. But that concludes my talk. Oh, that was 14 minutes. So please, one of the reasons I'm here is to introduce the public to these workflows, and I welcome feedback. I will not take them personally. Only my grandma will make me flustered, but yeah. So I welcome feedback. I will ask you guys to venture to the tutorials, and if you're a professional in a certain space and I didn't touch on certain things, I welcome all that feedback. They're there to be edited. They're not fixed in time or space. Okay, questions?
Okay, questions. You're too eager to start, Tonian.
I'm sorry.
No, that's fine. So questions? Yes.
Hi, Tony. Question, and I apologize if I blacked out while you were talking about this during your talk, but spatial querying for Landsat images, is that a part of the architecture?
Yes.
Okay.
Spatial querying meaning using a JSON, right?
Or meaning using like just I tuned in when it was, you can search by band and path number, but you can search by like, give me all the images that intersect my point of interest.
Yeah, definitely. We have so many tutorials on that, even some quick guides on how to create JSONs to do all of that, and different polygon shapes. Yeah. It was me, honestly, just testing random stuff, and I was like, users might want to know this. So I'm like, let me put it as a quick guide. And so we have quick guides that show you how to make JSONs on the fly and to get data, yeah.
Okay, cool, thanks.
Any more questions? Yes.
Just curious, what's the overlap between the USGS data you're showing here and the Esri Living Atlas? Because lots of it is accessible versus the Living Atlas, right?
Do you mean Landsat on Esri Living Atlas? Or?
Just USGS data sets in general, not Landsat specific. How much of it is already on the Living Atlas?
I'm not sure. Zachary, who works in DPAS, which is Data Archives, will probably give you the best answer to that. Not Zachary, Zachariah. Sorry, Dykus. And what is your name? I could help let him
Thanks.
get back.
Raviv, I'll talk to you after.
Okay.
Thanks.
I just had a quick question, and you might have shown it, and I might have missed it, but most of these data sets are like on Stack, presumably COG at the asset level. Do you also have ZAR or COPC, or is that another department, so to speak?
So yesterday, Zachariah Dykus, he gave the talk to get the feel out on what the users think about Landsat possibly moving to ZAR. So currently we only have COGs available for you guys. But currently it's really a feel out, so we can make a decision in the next 6 months if we'll be switching to ZAR for collection 3 in the next 5 years.
Or perhaps as an option, or is it just too much data? It's going to be one or the other.
It's going to be one or the other.
Yeah, okay, fair enough.
Funding.
Any more questions? Okay, great. Thank you.